Today I'm going to show you that how to check whether the number is prime or not. So first of all you need to know that what are prime numbers. So you need to focus on what are prime numbers. So it is either divisible by itself, divisible, it should be only divisible by itself or 1, right? So the this is basically the definition of the prime number. So here I need to focus, I need to build the program so that it can be tested whether the number entered by the user is prime or not. So I'm writing hashtag include studio.h int main. I'm going to ask n from the user, int n, printf enter n, printf enter n, or you can say enter the number. Then you have to take the number from the user. So scanf %d, because I'm taking the int value, the data type is integer. Scanf %d ampersand n. Okay, now what I have to do is that after taking the input from the user, I need to check if the input entered by user is divisible or not. So I'm going to create a container where I'm going to mention int is prime, and I'm going to mention it equals to 0. Or no, not that. You can instead do that, you can create a container, and in the later case what you can do, if n entered by the user is smaller than or equals to 1, then you need to set the value that is prime equals to 0. Only if when the n entered by the user is smaller than 1, otherwise it is gonna to stay 1. Now I'm going to create a for loop and I'm going to start from 2, because 1, like we all are aware, like if a number is in prime number, like every number is divisible by 1. Sorry, whether it's prime or any number, it's divisible by 1. So I equals to 2 and I greater than or equal, or you can product it, I into I is greater than, it should always be, and n should always be greater, and I should be always greater than I plus plus. And if this condition is satisfied, and if n modulo I is equals to 0, then what I'm going to do, that is prime, instead of is prime I'm going to write equals to, is prime equals to, if it's 0 then is prime equals to 0, and then I'm going to apply the if else condition. If is prime, printf %d, the number is prime. Or in the else case, I'm going to write else printf the number is not prime. The number is not prime. Then I'm going to return the value as 0. Return 0. return 0. Now let's run the code and check once. Enter the number. I entered suppose 5. Why is it showing the garbage value? Let's check the code. Enter the number. Is prime if it is smaller than 1. So 5 is, if 5 is not the smaller than 1, then it is set as 0. Then for int I equals to 2, I greater than or I should be greater than equals to n. Suppose it's 5, then 2 into 2, 4, and then it is going to enter. If n modulo I equals to 0, is prime equals to 0. If is prime, okay, and it's very important to write over here break, otherwise loop will keep on going. Now it is going to show the correct value. Enter the number 5. Still it's not showing. If n modulo I, if 5 modulo I, which is 2, equals to 0, then the value is going to be set as 0. Otherwise it is going to be 1 only. And in the next case, it will not go inside the loop because 9 is not smaller than 5. Then is prime. If is prime, printf percentage d is a prime. Okay, one more mistake we did. Sorry. It was like I have to here enter the value of n. Then only n is going to be printed, right? In the same manner, here also I need to print the value as comma n. Then return 0 is going to be printed. Let's run the code. Enter the number. I entered 5. 5, the number is prime. Again, let's run the code. Enter number 6. The number is not prime. And you might be thinking that why this time percentage d we didn't include it. That's why it didn't got printed. Enter the number. Suppose 64. 64, the number is not prime. And always remember to put a space because space is also counted. I hope it would have been clear, and the mistakes which I did, don't repeat that, because these all are the silly mistakes we often make. And how to apply this logic specially, because we all know that 1 is always divisible. One is the factor of all the numbers. So we started from 2 and we put such condition where it would be greater than or equals to n should be greater than. And once we are checking the n should be greater than, then we are breaking the loop over here. So this was all for today for checking the prime numbers. And make sure you dry run the things. I understand that in coding it's not like that you are going to understand each and everything at once. For me also sometimes it takes a long time to understand the thing but what I never stop is doing the dry run. So just wherever you don't get the concept, dry run the things. So this was all for today. Thank you very much and keep smiling.